Good afternoon, everybody. This is Charlie Fleischman. I'm with Pennsylvania Crusher, or TerraSource Global. Pennsylvania Crusher now is a brand name of TerraSource. Before I jump into this, unfortunately, we've had a number of power outages in our building today. They apparently are doing work down the street. And if we lose you during the course of this presentation, we'll try to reschedule this, Kim?
Yeah, we'll send an email to everybody,
all right,
letting them know when.
Unfortunately, it's out of our control if that does happen, but it's been sporadic all day long. We're going to cover today Pennsylvania Coalpactors. The name Coalpactor is a registered trademark for Pennsylvania Crusher, and I will be going through the background, explaining how we started with this particular type of crusher. I'll go through how it started really within the steel industry. We then recently, within the last 10-15 years, made improvements to it to use for flue bed boilers in the utility industry, and there may be some other applications as we go along. I will point to that, talk about the maintenance, and some new innovations that we've come up with, and then we'll have a question and answer session. Thank you. In case anybody wanted to know, that's me. Things to remember. We will be muting all lines until the end of the presentation. And we ask that you submit your questions, and we'll get to as many as we can at the end of the presentation. And also, this presentation will be recorded. I already roughed out pretty much the agenda for what we're going to do today. The Coalpactor is a reversible impactor. If you have attended our other webinar sessions, we went through Crushing 101, where we talked about how there's 4 different types of methods of crushing, and the crushing on this particular crusher is strictly through impact. It is done with a hammer swinging in the air. It is free impact with the material that we are going to crush, and it's just like a baseball bat hitting a ball. That is the only method that we're using, and I will, as we go through the applications, we'll talk about that more. Initially, back in the early 1950s, the Coalpactor was developed specifically for the steel industry. At that time, immediately after World War II, Pennsylvania Crusher was selling hammer mills, which is the type of hammer mill that we were selling to the steel industry, had screen bars or screen plate in it. All the material had to pass through the bars or the plates, and the effect of that type of crushing, which was actually impact and shear, did a great job in controlling the top size, but it generated too many fines at the bottom end of the product size gradation, and that caused a problem when they were making coke in the coking ovens. Those fines in the steel industry are called bug dust. Typically 140 mesh and less is what they're trying to minimize. All right, sorry, 100 mesh. One of the things the steel industry came back and worked directly with Pennsylvania Crusher was that they went through exercises and experimentation with their coking ovens and found that the 80 to 85% passing 1/8 inch was really a critical number for them. The top size was important but not as critical, and again, the bug dust, minimizing the amount of fines, was important. We took, after we did experiments here in our lab, we converted a couple units at some of the steel plants, and then we went around and we converted probably most of all the existing hammer mills into Coalpactors, and then went on to design a new series of crushers just to meet the Coalpactor requirements. What you see on this particular slide here is the design that was finally developed in 1950s, specifically for the steel industry. It's a reversible machine. It's center fed, which means you can reverse in either direction, and we would recommend that this machine be reversed on a regular basis to keep the hammers sharp and uniform to wear. At the bottom of the crusher, at this point here, I'm showing you an area, is what they call dust deflectors. And it was an attempt to minimize the windage coming out of these crushers. One of the effects of all of our crushers running, whether it's a granulator or a hammer mill or an impactor, is that you generate windage from the hammers coming around. And that windage with the crushed material tends to get blown around the plants unless they have good dust control collection. And these dust deflectors at the bottom of the crusher works sometimes depending how they're set up. Probably the biggest detraction from using them is that it is in direct path of the coal coming through the crusher, and they tend to wear out. Good for spare parts, but when they wear out, it's not helping anybody. So a lot of our customers did not replace them after they wore out. These crushers typically were direct connected to a motor. They were not V-belt driven. The output size control is maintained first by the speed of the crusher, and then secondly, the adjustment of the breaker plates. And these breaker plates here, it's probably not a good color to use. Let's try this color. These are the breaker plates here that I've shown in yellow. Can be pulled in or out with the synchronous gauge adjustment, so that you can take this breaker plate and move it in tighter to the hammer circle or pull it back. The biggest control on product size is done by changing the speed of the crusher. And that was typically, the speed of the crusher typically was selected based on the friability of the coal. And friability of coal is typically determined by hard growth index. In the steel plants, they will use high vol coal, low vol coal, medium vol coal. They tend to mix them all together after they're crushed. And if you have a high vol coal, that will be softer there. High vol high vol means higher hard growth and it's softer. So we would run the crusher at a slower speed. Low vol is lower hard growth and that is harder. Some of the plants typically had 2-speed motors, so they were able to run these crushers at 900 RPM and then at 720. I think we did that slide already. So going from the steel industry, we had a very long lag period of time where we did not sell a lot of Coalpactors. But what we had presented to us here as a marketing challenge was that fluid bed boilers, which is a type of crusher that was designed and built by companies like Foster Wheeler and Alstom, required a particular product size gradation for the boilers for fuels such as coal, petroleum coke. And we were looking for a way of how to meet their goals. We tried to use hammer mills, and in some cases it made way too many fines. Again, it controlled the top size. The Coalpactor that we had designed for the steel industry didn't generate, or the top size of the product size for the steel industry Coalpactor was too coarse for the fluid bed boiler. So we needed a way of improving top size control. And we took a look at the Coalpactor, and if you see here, that at this point here, about coming across here, the Coalpactor, the breaker plates stopped at about the 3 o'clock position. And we considered, what if we took the dust deflector plates out of the crushers, which weren't effective anyway, and then extended the crushing path. So we went from the 5 o'clock position down to about the 3 o'clock position down to about the 5 o'clock position, and increased the crushing path by as much as 30%. And we tried it again in our lab here, and we found that it was effective to get to the top size we needed for the fluid bed boilers. So, if you were to compare these, this is what we call a BC Coalpactor on the left-hand side, and on the right side we called it a BC Coalpactor type FB, which stands for fluid bed boiler. And you can see from this slide here, the difference between here and here is that we added more crushing path to the crushers, increased the length of the crushing path. And again, this was done to control the top size, get better top size control for fluid bed boilers. It also, with an open bottom, when I say open bottom, this is what we call an open bottom type hammer mill. All the material is passing out the bottom of the crusher. It is not going through any screen plates or screen bars. So the particles that are typically already at 1/4 inch and smaller tend not to get crushed any further. Now, that all being said, we still thought about, well, what if we wanted to get back and maintain the other the Coalpactor that we built for the steel plant, because the customer had coal or the fluid or the petroleum coke was softer, or the fuel they were using didn't require the longer crushing path. So we built the breaker plates with removable sections at the bottom, so that you could adjust the crushing path. So going back to speed controlling product size on the Coalpactor again, we can do it through speed control by changing the speed of the hammers. In other words, if you run this thing faster, the tip speed on these hammers will generate more force. We do that through we can do that through a reducer, or we can do that through a V-belt drive. On some units out in the field, not a lot, we have put on variable hydraulic couplings, so that we can change the speed, or the customer can change it, because they have different types of fuel coming in every other week. So they change the crusher speed to match the fuels that they're getting, so they get the right product size. The adjustment of the breaker plate on the Coalpactor is done using a synchronous cage adjustment. Again, the breaker plate is adjusted into the hammer until you hear a tick when there's no material running in the crusher, and then you back off the breaker plate. The purpose for being able to adjust the breaker plate is, as the hammers wear and the breaker blocks wear, you can compensate for the wear of those components. All of the Coalpactors, particularly the FB type Coalpactors, are designed in such a way that the end doors can be swung open, and you have full access to get into inside the crusher, so you get to the maintenance on the hammers and the breaker plate cages. We have a design with a hydraulic door opener, so that these doors can be opened quickly by just taking the bolts out between the end door and the frame, and then hooking up the hydraulic door opener. You can swing open the cage, swing open the doors. As it says here, this is an option. You do not need to have hydraulic door opener to get these doors open. It can be done using a chain fall and come-alongs. The design of the hammers inside these units are done in such a way that every other row is staggered from the other row, so that material does not pass through between the hammers. What I'm saying is that this row, this gap here, is opposed by a full hammer in the next row. So we call that a staggered hammer arrangement. the rotor on these machines will be pulled straight up. On some of the later units, we have designed it so that the frame actually can be pulled off, unbolted, and the rotor assembly can be pulled out in this direction here, so you do not have to lift it straight up. The advantage of doing that is that then you don't have to remove the chute work above, or if they have a screen, it makes it a little bit easier for the removing the rotor by being able to pull it off to the side. Here's an installation in Poland of a BC 507 FB. The 507 has a 50-inch rotor diameter, and the 7 in the model number indicates the width or the length of the rotor. This particular unit is probably about 102 inches long, and you can see here hydraulic door openers on this, and has a vibrating feeder. This is probably a pretty good installation for how to feed a crusher. The vibrating feeder goes across the full width of the rotor, and it has a straight drop going down into the crusher. This is another view of that same installation. This photograph was taken in our shop. It shows the rotor assemblies with the pillow box not on it, but the bearings mounted on it. These crushers all use our forged steel hammers. The smaller units, when I say smaller, 44-inch diameter units, are 16.5-pound hammers. A 707 type unit, which is a 70-inch diameter machine, will use our 50-pound forged steel hammer. Again, this is another view. This is actually sitting inside. Here you can see the rotor assembly sitting inside on the frame. The sides of the frame, these are bolted on side frames, are removed, and you can see how easy it is to, if you have to remove the rotor assembly, instead of lifting it up, you lift it up a little bit and you can pull it out the side. Unit going out the door from our shop. Here you can see the crushers are set in place at a plant on concrete foundations. The rotors are sitting in the back. These were shipped separate. The rotors were shipped separate from the crushers because of the size of the units. This unit probably weighed in the area of about 80,000 pounds. These are BC 707s. Here you can see the photograph of the back of the breaker plate, and it shows how we have this thing designed so that you can unbolt the bottom part of the cage and shorten up the crushing path. Again, this is another photograph in our shop. This design that I'm showing now is one of the earlier designs. This appears to be probably a BC 505. And the reason I know this is an early design is because the cage adjustment is up high on the unit. What we did on the FB design is we moved this cage adjustment, we dropped it to the bottom down here, and we hinged the doors so you can have full access to get into these crushers. Get another view in our shop. One of our recent developments now, as we've continued to try to improve our product lines, is that if you look at the cage assembly, they're all fabricated, and even though it's made from a hard material, AR400, we thought it might be better to put in a cast breaker plate assembly for several reasons. You can see in this photograph here that the material is packed in between the breaker plates down in here, and also here, and it required to clean them out. You had to chisel that out, and it was pretty time consuming. Here you can see another view. Required removing the bolts here. It just wasn't very maintenance friendly for removing or doing maintenance on the breaker plates. So we looked at these arrangements here. To the left you can see the fabricated arrangement. To the right, this arrangement here. We changed this to casting. You can see on this particular slide, on the left it's the previous design, plate design, and on the right, the new plate design. Now, one of the things this effect did was that the depth of these washboard effect, if you want to call it, was not as deep as what you had on the fabricated ones. So the material didn't build up in there, didn't pack in there as easy as it did on the other one. Here you can see we have a unit out in the field. We had, on this particular installation, we had the fabricated unit in here, and now we switched it over to a casting, and it made changing out the breaker plate easy. The other advantage is that it helped make the product size more uniform without someone having to go in there and do a maintenance. It was more consistent over a longer period of time. Here you can see someone standing next to this breaker plate. This was out of a 7/8" diameter Coalpactor, big unit. Any questions?
At this time, everybody is now taken off of mute. There were no questions through the Q&A section, so if anybody has any questions, please feel free to hop in.
Charlie, what is the difference between metallurgical coal and coal that's typically burned in the utility?
The metallurgical coal that we find at the steel plant has low sulfur and low ash, and it's a pretty clean coal. Out in your neck of the woods, I don't think there are a whole lot of mines out there, except for the one where we just sold the sizer at western part of Colorado. And I think they reopened that plant back up. It had been closed down for a while. Utility plants are burning, can be found burning coal that may have ash in there, I don't know, 10, 12%, whereas metallurgical coal may only have 3 or 4% ash, and again, low sulfur. Tom, did that answer your question?
Thank you, it does.
Okay, you're welcome.
Do we have any other questions?
Charlie, you've talked about, the machine originally designed for coking applications.
Mm-hmm.
And fluidized bed boiler because of the fuel curve that you need to hit.
Yep.
Have there ever been this machine used on any other types of application?
No, we have not tried it. I've thought about using this from time to time on limestone, but I've never found an application where I thought it would be acceptable. For instance, on the fluid bed, on the flue gas desulfurization, I'm able to get what I need on our reversible impactors, CAL types or CA, and I think it's a little less dollars to go that direction than use this machine. So, if you have a suggestion, we're willing to.
No, I was just trying to make sure there wasn't some.
No. It's something I think about. I have thought about that, and sometimes you guys come up with ideas that we hadn't thought about.
How does this compare to the TerraSource?
A TerraSource, wow. Well, the TerraSource's got hammers in there, probably weigh about 300 pounds. These have about 16.5, maybe up to 50 pounds. And the TerraSource's a Muse, and it's a flat wall, so yeah.
Doesn't have breaker blocks inside.
Different type of application.
Do we have any other questions?
Would you like to talk a little bit about the market for these?
Yeah, the market typically has been steel plants and for fluid bed boilers. Our biggest market area has been overseas in China, Philippines, Indonesia. Number-wise, I'd say in the last 5-6 years, we've probably sold 100 of these for the fluid bed boilers over in China and in that area of the world.